Now let's take a look at example number 3. You can see here right away that I'm going to have to make some adjustments to this problem since we weren't in class together to actually discuss this. But let's take a look. I want to go ahead and try to spin a spinner ultimately to see if a probability of m is going to make sense to us. Now let's go ahead and try to lay the groundwork here for what I mean by probability of m. So I'm going to change it up a little bit. How about we let m represent spinning the following colors on our spinner that we have over here. I have my spinner with all these different colors, and I want m to represent spinning either a blue or a pink or a gray or an orange. Now if I look at this spinner here, I can see that each one of the sections has an equally likely chance of occurring because they're all the same size. And so it would seem like the chances of spinning one of those colors, or having that event m happen, would be 4 out of the 6 total options. So I want to go ahead and see if 4 out of 6 seems to make sense here. And I'm going to do this by simulating spinning the spinner 18 times and recording my results, or my spins, below. Well, I'm going to go ahead here really quickly and just think about how I would actually record my results. Well, first, of course, I need to spin my spinner 18 times. I can spin it once, spin it twice. Clicking this obviously 18 times becomes a bit much, so I'm going to go ahead here and just say, let's spin 15 more times. Okay, now my table here gets populated, and I can even take these numbers directly off of here and record them down. So it looks like I had blue and pink happening 3 times. I had gray and orange happening 5 and then 4. So gray happened 5 times. Orange happened 4 times. And then green was 2 and red was 1. Green happened 2 times and red happened 1. Well, according to this little experiment that I ran, I could see actually what does the probability of m appear to be. Like, based on what I got here, 8 out of 18 total rolls, how many times did I actually get m to occur? Remember, m was going to be rolling or spinning a pink, a blue, a gray, or an orange. So I'll say here that we saw that out of 18 spins, we got the event m to happen. Let's see, how many total times? Looks like 6, 11, 15 times. Well, what that means is that we would say that our probability of m should be roughly equal to 15 out of 18. Well, if I look at what 15 out of 18 actually is, if I was to go ahead and pull up my calculator, I could see that 15 out of 18 gives me about 0.8333. So if I go back, this would be 0.8333. Now, this is kind of weird because this says that this is about like 83%. But when we thought about it up here at the start, we would have guessed that it would have been roughly 4 out of 6, or 66. Well, let me write it as a decimal, but as a 0.0 or 0.6667. So, because again, there were 4 equally likely choices out of 6 that were going to make m occur. So, why are these numbers so different? This is a really important thing for us to understand here in this first section of probability, because it really is driving home an important point of what probability is really attempting to tell us. When we say that something is going to have a 0.667% chance of happening, I should be able to notice that obviously, like we saw in Part B, that doesn't always happen over the course of a couple of tries. Out of 18 spins of the spinner, I did not end up with exactly what I expected to end with. However, I could start to see what begins to happen if I was to continue to spin the spinner. Notice that if I was going to continue to spin the spinner, let's say I spun it an extra 1,000 times. Well, now I can start to see that, let's see, if I wanted to get a grand total amount for how many times I was going to have my different colors here. Notice I'm adding up my blue, pink, gray, and orange. I now have 668 times out of 1,018 spins. Well, if I look at that, notice, am I getting closer to that percentage that was the 0.6667? Yeah, I actually was. I was getting a lot closer. Notice if I spin it maybe, say, another 10,000 times, I could start to see how these probabilities will adjust. Again, I can see now that if I was to restart everything I have here and add up all my numbers, I've spun M, or I've made M happen 7,318 times out of 1118. Notice I'm getting even closer to that 0.6667. So that probability that we would have thought at the beginning, that 4 out of 6 chance, what that's really telling me is the following. It's telling me ultimately what happens in the long run. So probability is a measure of what happens in the long run. That is, if I continue to repeat the trial over and over. So I'll say, that is, what will the relative frequency, which is kind of what we were computing here, the percentage of the time that something happened, or what we called the relative frequency, what the relative frequency will be approaching as the number of trials continues to increase. So that measure of probability is telling me that if I continue to repeat this experiment over and over, I don't just spin 18 times, but I spin maybe 18 million times, then this percentage here will slowly begin to approach the value that I calculated up here. So probability is a measure of what will happen in the long run. And this is why at the bottom of the page here, you'll see I have listed in this box what we call the law of large numbers. That as an experiment is repeated over and over many, many times, what we call the empirical probability, which is what we're seeing in the moment, will actually begin to approach the theoretical probability, which is what we would have calculated back at the beginning. So we have theoretical probability is what we calculate by saying like, 4 out of 6 of the items are going to get me what I want. Whereas empirical is by saying, let's take a look at actually what happened in the last 18 spins. So as we go ahead and repeat our experiment many, many times over, then we understand that the theoretical probability will begin to be approached. And so this provides us with an important idea. In the short term, probability is not very meaningful. It's still, though, an indication of what we should expect to happen. It's just that we can't always expect that will happen in that exact moment. You think about this like when the weatherman gets on TV, right? The weatherman's giving you a percent chance that it's going to rain. That is, he's really trying to tell you that if you were to kind of repeat the day over and over and over again, right, the chances that it would rain would be this. But of course, on any given day, we know that the weatherman could be wrong. Chances are, they're probably right about that, but it's always the case that things can be a little bit unlucky. So probability is this measure of what happens in the long run. And it's an important thing for us to keep in mind as we think about how we use probability in the sections to come.